Okay. Um, Hello, everyone. I'm Sandy from Department of Food Science and Nutrition in the Hong Kong Polytechnic University. So today, the topic of my presentation is navigating the future of Metaverse education, a comparative study of VR and non-VR learning environments. So this is the outline of my presentation. So the general background of this study lies in food education, especially the challenges in the teaching of food processing. Food processing is a very important part in food education, and which is usually taught by showing the flow diagrams in the lecture, just like this one. However, the plain flow diagrams are not quite effective in knowledge construction and may result in significant loss of learned knowledge shortly after the instruction. And also in practice, the food processing industry should look like this. So if the students can enter the plants and feel about the processing procedures in person, then learning the food processing should be much more effective. However, it is difficult and also not feasible to arrange industrial visit for every food production line, especially in Hong Kong, where there are not lots of food processing industries. So we need to look for an alternative which can create an immersive learning environment and can mimic food industry, food processing in reality. And then the idea of using Metaverse to build virtual food processing plants came to our mind. And nowadays, Metaverse has been widely used in different areas, such as healthcare, marketing, real estate, digital economy, simulation, and also teaching and learning. So based on that, our objective is through the utilization of such kind of immersive learning platform, students could have an authentic learning environment, which can help them change from passive recipients of information into active participants in the learning process. So for this research, this study, the research question is that, can the immersive technologies like Metaverse significantly enhance the engagement of students and learning outcomes compared with traditional educational methods? And if yes, what are the key factors affecting students' intent to use the immersive technologies for learning? And now I would like to talk about the methods used in this study. So for the experimental design, the participants in this study are 33 students aged 17 to 19, taking my course of food engineering and processing. And they need to complete the lecture content first and then experience the Metaverse learning environment. And the students were randomly assigned into the VR and non-VR groups. And the VR groups use the Oculus Quest 3 headsets, while the non-VR groups use iPads to experience the content. And the two groups of students, they were situated in different rooms so that they can independently engage with the same educational content. And this allows us to compare VR's effectiveness with the mobile learning methods, basically it's the iPad. So this is the Metaverse platform design we use. So it is an immersive simulation of a corn processing plant for students to learn corn milling. And this is actually the flow diagram I taught in the lecture. And then for the Metaverse platform, it includes like the avatars and objects for the students to interact with. And the students need to complete a series of tasks on the platform based on the knowledge that they have learned in the lecture and also based on the knowledge that they have obtained through the interaction with the avatars and the objects. And students could actually engage with the content in the Metaverse through different ways. For example, they can engage with through the multiple choice questions, the video explanations, grab and drop tasks, and also some avatars on the platform are powered by ChatGPT. So students can chat with these GPT-powered avatars for any issues they don't understand regarding to the core mailing process. And for each GPT-powered avatar, they were preset with customized keywords to make sure it can deliver content relevant to the learning objectives of core mailing. So after students complete their tasks on the Metaverse platform, they were invited to fill in a survey. And we use the data from the survey to determine students' perceptions and also acceptance of the design Metaverse. And we adopted the Fussell Truong's technology adoption model, which is a model specifically adapted for virtual reality. A focus on both the pedagogical effectiveness and technological integration. And it incorporates the following constructs measured on a 5-point Likert scale, such as the constructs like you can see like the immersiveness or intuitiveness or functionality of the technology, the attitudes of students towards learning in the Metaverse, ease of use, enjoyment, perceived productivity, or whether they consider it is effective compared with other e-learning methods, and practical utility, health, impact, okay, so on and so forth. And for the data analysis, we use the following methods. So we use descriptive statistics to investigate the central tendency and the variability of responses from the students. And we use independent sample t-test to compare the study performance between the VR and non-VR groups. And we use Spearman's correlation to see the relationship among different variables in the construct. And we use linear regression to further identify the key predictors of students' intent to use the Metaverse for learning. So here is the results and discussion. So for the analysis of descriptive statistics, the Cronbach's value of 0.914, it indicates excellent reliability of the scale used in this study. And meanwhile, from the mean values of the constructs, we can see that students have very strong enjoyment, positive attitudes towards the immersive learning technology. And they also have high perceived productivity, which means they consider the immersive learning technology more effective compared with other e-learning methods. And also from the Shapiro-Wilk tests, we can see that it confirmed non-normal distribution for all variables so that we can use non-parametric statistical methods in our analysis. And the independent samples t-test show that only one item in the construct of technology has significant difference between the VR and non-VR groups. So the users of VR headsets, they reported that the user interface is more intuitive and easier to navigate than those using the mobile, the iOS devices. So it indicates that VR may better align with human cognitive process for spatial and experiential learning. And also, what's interesting here is that for the health construct, we don't find significant health difference between the VR and non-VR users. And for Spearman's correlation analysis, we can see several significant relationships among the variables. So first, we can see that students' intent to use the Metaverse is strongly correlated with their positive attitude, ease of learning, enjoyment of use, and also their perceived productivity over other methods, okay, whether they consider the Metaverse is more effective than other methods, and also the perceived usefulness. So whether they consider the metaverse is useful for their learning. So all of them is strongly correlated with their intent to use the metaverse. And another significant relationship is that students' perceived usefulness of the metaverse is closely correlated with their positive attitude, the ease of use of the platform, their enjoyment associated with the technology, and also their perceived efficiency, productivity over other methods. And interestingly, from the construct of health, we can see that the concern about positive, negative health effect actually doesn't affect the intent to use the metaverse for their learning purpose. So which is good because we don't want the health concern affect students' intent to use the immersive learning environment. So then we use linear regression to further investigate the most significant factors that determine students' intent to use the immersive learning environment. So based on the F value from the ANOVA results, we can see that the regression model shows good fits for the data. And specifically, we find that the perceived usefulness and perceived productivity are significant predictors of the average intent to use the metaverse, explaining 62.6% of the variance. So this is the most significant results we obtained from the linear regression. So in order to improve students' perceived usefulness, here are some recommendations. So we can actually design the content closely related to the lectures. We can showcase more practical applications and also align learning modules better with professional and academic standards. And for the perceived productivity, the students, if we want to enhance this part, we can enhance the platform performance and also simplify the user interaction to make it easier for new users to start learning effectively right away. Okay, so also we have collected some comments from open-ended questions, and the positive comments are basically like it is interesting, it's more realistic, our knowledge is interactive, it's quite new to learning. And for the negative comments, it's basically from these three aspects, like the technical issues, physical discomfort, and user experience issues. So we can see that although VR has found to have better intuitiveness, the technical challenge remains to be a significant negative factor to user experience. And also the physical discomfort indicates that a VR headsets cannot be applied for a long time. And also, as mentioned before, we should simplify the user interaction to make the learning platform clearer, with more effective, which can make it more effective with better user experience for the learners. So here is the conclusion of my study. So we find that students showed positive attitudes, enjoyment towards the utilization of the metaverse, the immersive learning technology, and consider it's more productive than other e-learning methods. And we compared VR and non-VR groups, and we find that VR is more intuitive than the iOS interface, and they have no significant health difference, but still we need to strictly control the application time to minimize the discomfort. And to increase students' learning intent, we can enhance the practical utility of the content and focus on technical improvement to optimize the platform performance and also simplify user interaction. So this is my presentation. Thank you.